Hello friends, welcome to our channel Learning is Easy. We will start with the first topic, unit and measurement, part 1. So, unit and measurement. Friends, we all know that we need to measure a number of quantities. For example, size of object, volume of liquid, amount of matter, weight of any material, body temperature, length of cloth or any material, etc. etc. So, unit. The standard measures of any quantity is called unit of that quantity. Next is systems of unit. CGS, centimeter gram second system. MKS, meter kilogram second system. FPS, foot pound second system. SI system international. The first three systems, namely CGS, MKS, FPS, were used extensively till recently. In the 1971, the 14th International General Conference on Weight and Measures recommends the use of International System of Unit. This International System of Unit is called SI unit. Next is, what is fundamental quantities and units? This physical quantity which do not depend on any other physical quantities for their measurements are known as fundamental quantities. The fundamental units. The units used to measure fundamental quantities are called fundamental units. So friends, there are 7 fundamental quantities. We will see the table of fundamental quantities with their SI units and symbol. Length. First is a mass. SI unit is kilogram, symbol kg. Then is a length. SI unit meter, symbol m. Temperature, SI unit Kelvin, symbol K. Amount of substance, SI unit mole, represented by mole. Electric current, SI unit ampere, symbol A. Time, SI unit second, represented by S. Luminous intensity, SI unit candela, and represented by C. D. What is derived units? Derived units and derived quantities, which depends on some or all of the 7 fundamental quantities and can be expressed in a terms of these quantities. These are called derived quantities and their units, which can be expressed in a terms of the fundamental units are called derived units. For example, speed, momentum, resistance, conductivity, etc. So for example, SI unit of velocity is equal to unit of displacement divided by unit of time is equal to m by s. So this is an example of the derived quantities or derived unit. Next is a supplementary units. So besides these 7 fundamental or basic units, there are 2 more units called supplementary units. One is the plane angle and the other is a solid angle. One is a plane angle. So what is the plane angle? So plane angle is basically is the ratio of the length of an arc of a circle to the radius of the circle. Thus, d theta is equal to ds by r. Is an angle subtended by the arc at the center of the circle. It's measured in radian. Next is the solid angle. Solid angle is the 3-dimensional analog of d theta and is determined as the area of the portion of a surface of sphere to the square of radius of sphere. Thus, d omega is equal to dA by r square. Is a solid angle subtended by area ds at O. It is measured in st radian. A sphere of radius r has a surface area 4 pi r square. Thus, solid angle subtended by entire sphere at its center is omega is equal to 4 pi r square divided by r square. That means equal to 4 pi 3 radian. So after this, we will see what are the convention for the use of SI unit. First is unit of every physical quantity should be represented by its symbol. For example, small m for meter. Second is full name of unit always starts with a smaller letter, even if the name after a person. Example 1 Newton, 1 Joule, etc. But a symbol for the unit named after a person should be in a capital letter. Example N after the scientist Newton, J after the scientist Joule. Then the third point is symbol for unit does not take a plural form. For example, force of 20 Newton and not a 20 newtons. So it's mean it's in a singular form, not in the plural form. Then the fourth point is symbol for unit does not contain any full stop at the end of recommendation letter. So the example is 25 kgs and not a 25 kg full stop. Then the next point is fifth point, the unit of physical quantities in numerator and denominator should be written as one ratio. For example, the SI unit of acceleration is m by s square, or else m s raised to minus 2, but is not written in this form. The sixth point is the use of combination of unit and symbol for the unit is avoided when the physical quantities is expressed by combination of two units. For example, the unit of J divided by kg K is corrected, while joule by kg K is not corrected. Seventh is the prefix symbol is used before the symbol of unit. Thus, a prefix symbol and unit symbol constitute a new symbol for the unit, which can be raised to a positive or negative power of 10. 8th point is space or hyphen must be introduced while indicating multiplication of two units. For example, meter by second should be written as this format. So it's mean we had to use a hyphen or a space between, not the straightforward. So I hope you liked our video, part 1. So go and watch the part 2, and if you like it, to subscribe our channel for more interesting videos. Thank you so much.